Hello guys, and welcome to my YouTube channel. In the last video we were talking about types of functions, that is bijective functions, surjective functions and injective functions. And in this video we're going to solve a practical example based on those. So this is the question. We have been given f of x, we have been given our function, we have been given the domain, that is x is an element of R, where x is not equal to -3, and we have been given the codomain, which is R. And here the question is find the range of f and determine whether f is bijective. Okay, so firstly we're going to find the range of f. Okay, to find the range of f, let me just write back that equation, that is f of x equal to 2x plus 7 on x plus 3. Okay, to find the range of f of x, we need to find the inverse. And remember, in my last video I talked about the range and how to find the range. That was, take y equal to 2x plus 7, all that on x plus 3. Okay, so here we are going to make x the subject of the formula and find x. So we're just going to cross multiply. So here we're going to have y times all this and 1 times all this. So let's have y into x plus 3 equal to 2x plus 7. Okay, so we're going to open this bracket. That will be xy plus 3y, all that equal to 2x plus plus 7. Okay, since we are looking for x, we need to bring like terms together. So we're going to have xy minus 2x. That was, we brought 2 this way. When you send it over, the sign changes. So here was a positive sign. When you send it over, it's going to have a negative sign. So equal to 7, we send this to this way, the sign changes, minus 3y. Okay, so here we are going to, since we want to find x, we are going to subtract x out. We'll send x out of the bracket. That is x into y minus 2 equal to 7 minus 3y. Okay, so here we're making x the subject, remember, and we cannot leave it like this because x is not yet the subject of the formula. So we are going to divide both sides by y minus 2. So we have x into y minus 2 equal to 7 minus 3y. So we will divide both sides, y minus 2 here and y minus 2 here. This case will cancel. So we are going to have x equal to 7 minus 3y, all that over y minus. So here we have found x, but this is not yet the range. This is just the inverse. So here we can, let me just write it down for further clarification. Here we can see f inverse of x is equal to 7 minus 3. Here was y and here was y. So we change, wherever we see y, we replace it with x. So we are just going to say 7 minus 3x, all that on x minus 2. Okay, that is what we have. This is just the inverse of x. This is how we look for the inverse of f. So now we have to look for the range. The range is the same as the domain of f inverse of x. So this is the same thing. The range is the same as the domain of f inverse of x. So here we are going to have to look for the domain. Here we have a denominator. We have this denominator, and what do? We take x minus 2, we equate it to 0 in order to find our domain. So we're making x the subject of the formula again. So we have x equate to 2. So from there, we have to make a statement. Yes, we know x is equal to 2, but there's a way to write it in order to have your domain. So to have your domain, we have domain is equal to x, an element of real numbers, and x should not be equal to this 2. As you can see above in the equation, that was the structure of how they gave our domain. So this is the domain of f inverse. So here x an element of R. Yes, x is equal to 2. 2 is a real number. But here x should not be equal to 2. Why should it not be equal to 2? Because if you place 2 here, over here, it's going to be 2 minus 2, which will give you 0, and it will make our equation undefined. So x should not be equals to 4. So that is our range. Our range is equal to x, an element of R, and x should not be equal to 2. This is one way to write it. Another way, we can just say that our range is equal to real numbers. This is another way to write it. So anyway, which is easier for you, you can write it as thus. Okay, so we have found our range. Now we have to determine whether it is bijective or not. So our first step was range of f of x. So now have bijective. We need to determine whether it is bijective or not. So to determine bijectivity, remember in my previous video, for a function to be bijective, it has to be both injective and surjective. So let me just write back my equation. Okay, so first we test for injectivity. We need to test whether it is injective. Note, if you test for injectivity and if it is not injective, then you can conclude at once that it is not bijective, because for bijectivity it has to be both injective and surjective. But if it is not injective, then you can already conclude that it is not bijective. So let us start. Remember in my previous video, I said for injectivity, f of x1 should be equal to f of x2. So we're going to have, which is the same as x1 equal to x2. So when you substitute this and this in this equation, you should be left with this x1 equal to x2. So let's test and see. Okay, now we have this. Let's put it in the equation. So take the first one, f of x1. We have 2x1 plus 7 over x1 plus 3. So from there we have, that is it. Take the next one, f of x2 equal to 2x2 plus 7, all that on x2 plus 3. Okay, so we have that. Okay, from here we equate them. We have 2x1 plus 7 on x1 plus 3 equal to 2x2 plus 7 on x2 plus 3. This is what we have. So we cross multiply. We have 2x1 plus 7 into x2 plus 3 equal to, we cross multiply this and this, 2x2 plus 7, all that into x1 plus 3. Okay, this is a pretty long bracket. Okay, so now we open our brackets. We have 2x1 x2, so we're taking this and this. After we take this and this one and this one, this one and this one. That is what we are doing. So after that we have plus 2x1 in 2x1 times 3, okay, plus 7x2 plus 7 into 3 equal to, do the same, this and this, 2x2 x1 plus this and this, 2x2 into 3 plus, let me just step down, 7 into x1 plus 3 into 7. Okay, now let us simplify. So we still have our 2x1 x2 plus 6x1. 6, we have 2x1 times 3, so that will give us 6x1 plus 7x2 plus 7 times 3, 21, equal to 2x2 x1 plus going to give us 6x2 plus 7x1 plus 21. Okay, so this is what we have now. Okay, we are going to simplify. If we bring this way, we are going to have 2x x2 minus 2x2 x2. If you see, we have the same thing. We have 2x1 x2 is the same as 2x2 x1. So let me subtract them. Going to say 2 plus 6x1 plus 7x2 plus 21. So this 21 is equal to 21 is equal to okay, so now if you want to bring like terms, we are going to have 6x1. We send this way. We take all the terms with x1 to the left hand side, and we take all the terms with x2 to the right hand side. So all x1 left hand side. So we have this 7x1 over the equal to sign, its own sign changes. So we have minus 7x1 equal to, we still have a 7x2 there, plus 7x2 equal to 6x2. Okay, so we also send this way. So we're bringing like terms together, remember? Okay, so we have 6x1 minus 7x1 equal to 6x2 minus 7x2. Okay, so we're going to factor out x1. We're going to factor out x1 here, and we'll factor out x2 here. So we have x1 into 6 minus 7 equal to, we factor out x2 into 6 minus 7, 2. Okay, so now what's 6 minus 7 is just simply minus 1 x1 into minus 1 x2. So we simply divide both sides by minus 1. We'll cancel here and cancel here. So at the end we have x1 equal to x2. This is what we wanted. So from here we can say that the function f of x is injective. It is injective. So from there, we started off by saying f of x1 should be equal to f of x2. We substituted them in the formula, we equated them, and we solved and solved. And then finally, we have our proof. So, but that is not all. Remember, we are testing for bijectivity. So now, next, we need to determine whether it is surjective. Okay, so we have the next surjective. Remember, in my previous video, I said for a function to be surjective, the codomain of f of x should be equal to the range of f of x. Remember, in our question above, let me just go to the question. Okay, in our question, our codomain was given as set of real numbers. Our codomain must not always be set of real numbers. Sometimes they can give us like this. Sometimes they can give us in this form. but sometimes they can just tell us that it is a set of real numbers. And so remember I said the codomain should be equal to the range. So we know that our codomain is a set of real numbers. Now we need to know the range. But first, the range, we're told to find the range in the question. So we're going to have, okay, where's the range? We said our range is x should not be equal to 2. So if we combine these two, we have our codomain is set of real numbers and our range, okay, let me just structure this better, is x, an element of real numbers, and our range is x, element of real numbers, and x is not equal to 2. It is not the same. It is not the same. So here x is an element of real numbers, but here x, it has another condition. X should not be equal to 2. So they are not the same. So remember, they have to be equal, but they are not equal. Here x should not be equal to 2. So here we have to conclude that f of x is not surjective. Okay, from there now we can conclude that f of x is not bijective. Why? Because as long as f of x is not surjective, then it is automatically not bijective. Remember, f of x is bijective if f of x is both injective and surjective. So in this case, it is not bijective. Okay, that is all for today, guys. Thanks for watching this video, and I will see you guys in the next video.